Today we'll go through module 4, which is on game theory. As you know, in a business, many times a company makes decisions based on what the competitor does. So sometimes they take actions based on what the competitor does, and similarly a competitor may also take some actions related to the product or service looking at what this company has done. If we call this company X and competitor Y, so obviously X many times looks at what options or strategies competitor Y is choosing, and accordingly they may adjust their strategies. Basically, this type of situations can be modeled very easily using concepts in game theory. So game theory is very well suited for this type of situations. And this field was popularized by Dr. Nash, who won Nobel Prize around 1950 for developing what is known as Nash equilibrium. In fact, there was a movie made on the life of Dr. Nash called The Beautiful Mind, which is a very, very interestingly made film. Now, in this chapter, we are going to look at situations where number of players will be 2. So we are only looking at situations where are only 2 players involved, X and Y. And associated with those 2 players and the strategies they are using, we look at payoffs. And this also, we basically use a special case where payoffs are in the form of zero sum. So the total payoff is always 0. For example, based on a strategy by player X, it may happen that the gain by player X will be plus 5%. So if there is a 5% gain for player X, that also means that there will be a loss of 5% for player Y. So when you add these two, the total is always 0. So these type of situations are called zero-sum games. Another situation could be where player X chooses a strategy which leads to, let's say, 10% gain in the market share. And this gain is coming basically from the competitor who loses 10% market share. So the total is always 0. The third factor in game theory are number of strategies players can choose. Let's consider situations where these 2 players, X and Y, they choose 2 strategies. Suppose X1 represents the first strategy by player X and X2 represents second strategy by player X. These 2 strategies could be, if we are looking at say marketing, maybe first strategy is using TV for ads and second strategy could be using radio for ads. So based on this, player Y also will choose certain strategies, and let's say there are 2. In this table, let's say payoff is 3 when X chooses strategy 1 and Y chooses strategy 1. So this table is made with respect to player X. So if we see a positive number like 3, that means it is a gain for X and loss for Y. So let's say this value here is 5. So again, it is gain for player X. This is 1. Again a gain for player X. And this is negative 2, which means player X is going to lose 2 points. So now if you consider player Y and the strategies used by player Y, when player Y chooses first strategy, what will happen is, if X chooses first strategy, Y will lose 3, and if player X chooses second strategy, Y will lose 1. So maximum possible loss for player Y is going to be 3. So I'm going to write maximum values in this last row. Similarly, maximum possible loss for player Y will be 5. And basically what player Y will try to do is to minimize the possible losses. So out of the 2 values, player Y will choose this one. And the idea is very simple, because this payoff matrix, you can see out of 4 situations, 3 situations favor X. So obviously this payoff is biased towards player X. So Y is eventually going to lose. The only thing Y can do is to minimize that maximum loss. The criteria being used by player Y in this situation is minimax criteria, which is minimizing the maximum loss. This 3 here is called upper value of the game. Similarly, if you consider strategies used by player X, so what player X will try to do is, so if we create this last column where we put minimum payoffs, so in the first row minimum is 3. So minimum possible win for player X using strategy 1 is 3. Similarly, minimum possible gain by using strategy 2 is in fact negative 2. So what player X will try to do is, player X will try to maximize the minimum win. So maximum of the 2 is this value 3 here. So player X is using a strategy called max win criteria. And this value here is called lower value of the game. Now it happens in this case that the upper value of the game is equal to lower value of the game. And in fact, we can call this is the value of the game, which is equal to 3. So basically, what is this number 3? This number 3 is the average or expected game outcome if this game is played many times, like infinite number of times. So the game will converge at this value 3. So both player X and Y will use strategies in such a way that they end up with this value here. Basically it means whenever player X chooses first strategy, Y will choose first strategy. Similarly, whenever Y chooses second strategy, obviously player X will choose first strategy. So always they end up with 3. So whenever this happens, whenever both these numbers are same, we say that equilibrium or saddle point exists. Equilibrium or saddle point, so if you have this, so we have two situations. One is this point exists, and second situation is it does not exist. So whenever equilibrium or saddle point in a game exists, we say that we have pure strategy games, and when it does not exist, we say that we have mixed strategy games. So pure strategy obviously means that both players will always use one particular strategy to maximize or optimize their situation. And mixed means they may not use the same strategy all the time. They may change strategies. So let's say payoff matrix looks like this. So suppose payoffs are 2, -4, 6 and 10. Now if you have to figure out whether this is a pure strategy game or mixed strategy game, so we again apply minimax criteria for player Y. So if we find maximum value in those columns, so maximum is 6 and 10. So we select minimum of the two using minimax criteria. Similarly, if you find minimum in the rows for player X, so -4 and 6, so if we use max min criteria, so maximum of these minimum values, so the value is 6. So again, both are equal, so this is also a pure strategy game. So this previous example also you can see it is favoring player X, because out of 4 situations, in 3 situations it favors player X. So let's look at this one, x1, x2, y1 and y2. And suppose the payoffs are 10, 6, -12 and 2. So again, if you find maximum and minimum values, so you have maximum 10 and maximum 6 here, and minimum of the two is 6 using minimax, and similarly using max min 6, -12. So maximum of the two is 6. So again we have pure strategy game. So always only one solution will appear. So this game also favors player X. So maximum of the two is 2. So now they do not match. So obviously this is called mixed strategy game. For mixed strategy game, to find the expected value, like if the game is played for a long period of time, so what is the expected gain for player X or what is the expected gain for player Y? To find that, we have to do this analysis in slightly different way. It's not as straightforward as we have done in the previous examples. So we need to do some calculation to figure out what is the expected value for the two players. So I'm going to again make this table here slightly bigger so that I can write few other values. So, and let's say player Y plays strategy 1 p times and strategy 2 1 minus p. Proportion of times strategy 1 is played is p, and proportion of total times when strategy 2 is used by player Y is 1 minus p, so that the total is always 1. And p of is 4, 2, 1, 10. And similarly for player X, let's say first strategy is used q times, or proportion is q, and 1 minus q for second one. So expected gain will be, so 4 times q, so we multiply 4 and q. So basically we are taking weighted average. So we are using the weights as the proportion of times each payoff will occur. So 1 times 1 minus q. Similarly 2 times q for this one, plus 10 times 1 minus q. So now if we equate the two, what we are going to get here is 4q plus 1 minus q equals 2q plus 10 1 minus q. Basically we are trying to figure out what will be the value of qb. If you simplify this, you get 4q minus q is 3q plus 1, and if you simplify this, you get negative 8q plus 10. So you end up with, if you bring negative 8q this side, so you end up with 3q plus 8q equals 10 minus 1. So in fact 11q equals 9. So your q is equal to 9 over 11. So if q is 9 over 11, so obviously 1 minus q is going to be 2 over 11. So basically player X will play first strategy 9 over 11, like that will be the proportion out of all the time player X plays strategy 1, and similarly 2 over 11 for strategy 2. Now similarly if we calculate expected gain, so now we multiply 4 with p, so 4p plus 2 times 1 minus p, and then 1 times p is p, plus 10 times 1 minus p. So if you equate the two, you get this. If you rearrange, so 4p minus 2p will be 2p plus 2 equals, and this becomes 10 minus 9. 9 plus 2 becomes 11, and this becomes 8, so that p equals 8 over 11. Similarly, 1 minus p will be 3 over 11. So using this, if we want to calculate what will be the gain for or expected gain for y, so you can actually use any one of the two. Let's say I'm using the second one, so p plus 10 times 1 minus p. So if you input these values here, 8 over 11, 10 times, because 1 minus p is 3 over 11, so 3 over 11. So if you simplify this, you will get 38 over 11 or 3.46. Now expected gain for player y, and because we are getting this 3.46, which is a positive number, in fact this is a loss for player y, because the payoff matrix is made in such a way that any positive value means it is loss for player y and gain for player x. On an average, player y is going to lose 3.6. Expected gain for player x is going to be, so again we can choose any equation. Let's choose the first one, like this one here. So this equals 4q plus 1 minus q. So this becomes 3 times, because q is 9 over 11, plus 1. So this will give us 27 over 11 plus 1. And if you simplify this, you get 38 over 11, which is same number we got earlier, and we get 3.46. So these two numbers are obviously same, because this is a zero-sum game. So whatever player X gains, same thing is lost by player Y. And whenever we see a positive number for player X, it means it is a gain. And if we see a positive number for player Y, it is a loss. This time, let's say this game favors player Y. Payoff matrix is x1, x2. So again, if you look at this and find using the max min and min max criteria, you will see that the two values of the game do not match. So this is also a mixed strategy game. So let's assume that first strategy by player Y is played p times, and second strategy 1 minus p. That's the proportion, and this is q and 1 minus q. So if you calculate this value here, negative 4q and 0 times 1 minus q is equal. We can equate with equal to the value here, which is negative 2q plus negative 10 times 1 minus q. So we are using these values here in the payoff table and multiplying by the proportions. So if you simplify this, this whole thing becomes 0. So you are left with negative 4q. And if you simplify this, you get negative 2q, negative 10 plus 10q. If you bring all the q's on the other side, you will end up with negative 12q and negative 10, but negative and negative become positive. So q equals 10 by 12, which is same as 5 by 6. So 1 minus q obviously will be 1 by 6. Now if you do the calculation here, so this we did for the expected gain and expected gain. So if we equate the two, you get negative 4p, negative 2, and this becomes plus, so 2p equals. So 0 times p becomes 0, so you are left with negative 10 plus 10p. What you get here is negative 2p minus 10p equals 2 minus 10. If you bring all p's on the left and all the numbers on the right, and then we end up with negative 12p equals negative 8. But because both are negative, so we can make it positive. So we get p equals 8 by 12, or 4 times 2 is 8 and 4 times 3 is 12, so 2 by 3. 1 minus p is going to be 1 by 3. So based on the two, we can calculate expected values. So negative value for player X means it is a loss for player X. So for player Y, if we see a negative number, that means actually it is a gain for player Y. So you can see both values are same, but interpretation is different. So both are negative. So negative means loss for X, but gain for Y. So the way this idea is used is sometimes there are strategies which will never be used because the other strategies are so dominant that some strategies may not be used anytime by any of the two players. When somebody is working to find a solution, it makes sense to eliminate those strategies which are dominated by other strategies because that will reduce the size of the game and make things more easier to deal with. So let's say we have a situation like this. I will use example where player X has X1, X2, X3, three strategies for the game, and Y has two, and let's say payoffs look like this. So when player X will use first strategy, obviously player Y will go for the second strategy. When player X uses second strategy, player Y will go for the first strategy because that will minimize the loss. Now, in no case X is going to use the third strategy because the payoffs are very small. In fact, player X will do better if player X goes for second strategy because the payoff will be at least 2, which is 2 times. So this strategy will never be used because other strategies dominate this. So basically this can be deleted. So if you look carefully at this payoff table, you will find that player Y will never choose second and third strategies because player Y can win by choosing either first strategy or fourth strategy. So Y2 will never be used. Similarly, Y3 will never be used because the other strategies dominate second and third strategy. So again, if you look carefully, you can see that player X will never use first strategy because the gains to be made are much smaller compared to second and third strategies. So basically, the concept of dominance can be used to reduce the size of the game. And once the size of the game is reduced, at least that makes things much simpler to look at.